Okay, Jonathan here at Colfax Math. I'm going to go over adding vectors using component form. So if you have two vectors here given as a bearing off of north, and you want to convert to a component form, the key is that this is clockwise off of due north, and the first step is you're going to be using trig, so you have to go counterclockwise off of x. So here's vector A. It is 10 units long at an angle of 30 degrees off of due north. Or how far is it off of the x-axis? I know these two angles right here are complementary, so it would be 60 degrees off of x. So I'm going to take that vector A. The first step again is convert vector A in a trig as a counterclockwise off of x. So that's 10 units at 60 degrees. There's no notation here at all because it's off of x. If there's notation, it's a reference to bearing, meaning that you're clockwise off of north. My second vector, this blue vector, is 15 units long, and it's 100 degrees off of due north. So how far is it off of x? You have to kind of use your knowledge of vectors to figure, or your knowledge of angles to figure that out. So if this is 100 degrees, this would be 90 and this would be 10. So it's 10 degrees below the x-axis. So I could see that it would be 10 degrees short of 360 degrees. So I rewrite this vector as a bearing, as a vector with magnitude and direction off of x. It's still 15 units long, but it's at an angle of 350 degrees off of x. There are two ways to add vectors together. One is to kind of graphically do it, tail a tip, move that blue vector up here, and then find the resultant vector. And then the other way is with component form. So if it's in component form, I have a horizontal and a vertical component. The horizontal will always be the adjacent leg of a right triangle. So I'm going to convert this to component form now. The equation is the magnitude of the vector, cosine of the angle it makes with the x-axis, plus the magnitude of the vector, sine angle it makes with the y-axis. So that's how I convert it to component form. So this is going to be 10 cosine of 60 degrees. That's I plus 10 sine of 60 degrees, j. I'm going to do that with my second vector, my blue vector here. That's going to be equal to 15 cosine of 350 degrees, I plus 15 sine of 350 degrees, j. And the beauty is now I just add those together to get my resultant vector. So I'm in degree mode, but I'm working with degrees. Not only am I working with degrees, I'm degrees off of the x-axis. So I gotta make sure I'm in degree mode on my calculator. So I'm in degree mode. Now I'm gonna just take that, that's the number on my calculator. 10 cosine of 60 is equal to 5, plus 15 cosine of 350 is 14.7, and then I add those two together. So I take that value on my calculator and that value on my calculator, and it gives me 19.772, and that's my horizontal component. Now I'm going to do the same thing with my sine values. I have 10 sine of 60. This is 8.77, and then I'm going to add 15 sine of 350 onto it, and I'm going to get 6.05. So that's my answer in component form. So A plus B is equal to 19 in the horizontal and 6 in the vertical, and that's just your answer. If I want to convert it back into a magnitude and direction off of x, I can do that. or converted it into magnitude and direction off of the north. And it's just all right triangle trig, that's why it works. So let's go back here. If I were to do the tail at tip method, here, let me redraw this. So my first vector right here is 10 units long. My second vector is 15 units long down here. If I were to tail a tip it, I'd put the blue vector up here, and I would draw my resultant vector a plus b. So this a plus b would be from the tail of the first to the tip of the second. Okay, so that red is a plus b. And what I'm saying here with my component form is this horizontal component is 19.8 units long. This vertical component is 6.05 units long. And the way I got that was I figured out the horizontal component of that black plus the horizontal component of that blue, added them together, giving me the 19.8. I took the vertical component of that black, the vertical component of the blue, which was negative, added them together to get the 6.05. So if I want to convert my answer in component form back to a magnitude and direction, I have a right triangle here, so I could use the Pythagorean theorem. 19.8 squared plus 6.05 squared equals c squared, 428. Square root of c is 20.7. So the other way I could write this vector is it is 20.7 units long at an angle of, well, it's a right triangle, so I just need to solve for theta here. So I could say tangent of theta is equal to opposite over adjacent. Solving for theta, I take the arctan of both sides. So the arctangent of 6.05 divided by 19.8 gives me an angle here of 17 degrees. So this angle here is 17 degrees. So that means that vector is 20.7 units long at an angle of 17 degrees off of x. Or if I wanted it as a bearing off of north, here's due north. Again, I have to know this idea of angles and complementary and supplementary. This whole thing here is 90. So 90 minus the 17 gives me the 73 degrees. 73 and 17 is 90. So another way to write this is 20.7 at an angle of 73 degrees. But then I need to let the reader know that's off of the due north. So I could put a bearing on there, or I could just put northeast. So this notation at the end is saying I'm going clockwise off of north. No notation is saying I'm going counterclockwise off of x. And this is component form. So really the first step is given these two vectors as a magnitude and direction off of north, is convert them into magnitude and direction off of x, because I'm going to do right triangle trig. And then I just plug them in to the equation. Let me write that one more time a little larger. Into the component form. Vector A, component form is the magnitude of A, cosine of the angle it makes off of the x-axis. That's my horizontal component, plus the magnitude of A sine, right, opposite over hypotenuse, sine of the angle it makes off of the x-axis, J. And then that's my answer in component form. I go over 19.8, up 6.05, and then I use my properties of right triangles to find the magnitude and the angle.